Mr. Gagnon. Again, videos best played at 1.25 speed. YouTube likes to slow down the videos. So, we're going to take a look at something called friction. Okay, and when you were growing up and you went through elementary school and middle school, you learned about friction. And you learned that friction was something that was called an opposing force. Okay, and that's absolutely true, but we're going to get into some more details. It is an opposing force. It opposes motion. It opposes the applied force. It slows things down. So if we get the term friction, okay, I'm going to take and I'm going to draw a picture of what's happening here. So in friction, let's say I have a shoe. Okay, here's the laces. Okay, and I have a surface. Okay, it doesn't matter what surface that is. It could be a step or a sidewalk, whatever it is. I'm going to take it, I'm going to expand that drawing. Again, I'm going to not take it to the molecular level like we did with normal force, but I'm going to take it to a much larger level. So the bottom of my shoe is not perfectly flat. In fact, if it were perfectly flat, this shoe would slide along the surface. So, if my shoe were blown up a bit, I would notice that there were at the bottom of the shoe, okay, would look a little like this, like it's got a lot of bumps and peaks and valleys in it. If I were to take the surface here, the surface of the ground, okay, I'm gonna try to lock that in here. Okay, that also has, okay, peaks and valleys on the ground. Okay, now here's the shoe surface. Here's the ground surface. Okay, and notice how like these two guys, they lock together. And that's something that we call static friction. Okay, these are not moving. These are just stuck together. Stuck, static. Okay, you can use that as a little helpful tool. Stuck, static. Static is stuck. Okay, static is usually greater, and is always actually greater than moving. Okay, so I'll give you a situation. This is static. These things are stuck together. Now, if I have the shoe slide across that surface, what happens to those peaks and valleys? You got it. They actually they break and they become more rounded. So if this shoe starts to move forward, okay, it will start to break, what we call break, literally break the peaks off of the tips of all the little mountain surfaces. So if it breaks the peaks, we can actually say that it breaks friction. Okay, and this break point, okay, we're going to be talking a bit about that later. The break point is where the friction turns from static to something called kinetic. So it goes from static friction to kinetic friction. Static, remember, is static still. And we know kinetics, okay, we think of motion. So this is moving. Okay, so static is still, kinetic is moving. Now, I just said that static, as they say stuck together, static is still and stuck. That the mountains are locked into each other. So static, we're going to say force of friction, static, FFS, is going to be always greater than something called FFK. Yeah, you got it. That's kinetic, that's static. Okay, so the force of static friction is always greater than the force of kinetic friction. Okay, kinetic is moving, static is still. Just a real quick analogy. About a year ago, I moved into a new house, and I had to push the refrigerator across the deck. Yeah, I left a big mark on the deck. I have to take care of that. But I noticed that when I was pushing the refrigerator, that it was harder to get it moving than to keep it moving. And that just exemplifies this whole static kinetic friction bit. So the refrigerator, when it was static, the mountains and peaks and valleys were stuck into the deck. But as soon as I got it moving, I noticed that it was harder to get it moving. That means that it was harder to break the peaks than to keep it moving. And that was a good exemplification of static friction versus kinetic friction. Now, on the quiz, I'm going to ask you guys to give me some examples. I think I'm going to stop here as far as explaining friction. This will be an introduction to friction. We're going to get into some math in the next video.